Well, good morning, Honors Algebra 2. Welcome to my sunroom. I've got a huge whiteboard that I borrowed from my Sunday school class at church, and it's a sunny day, and so I'm sorry I've got a few little sun rays peeking through on either sides of the blinds of my windows, but I'm trying to make this as easy as possible on us. So I've simulated a whiteboard in my sunroom. So let's go ahead and talk about today's lesson. 10.5, absolute value in open sentences. Well, open sentence is just a fancy name for an equation or an inequality, anything with a variable. So we're first going to start by solving an absolute value equation. So here I have the absolute value of x is equal to 2. And what they're really asking here is what numbers have a distance from the origin of 2 units. So here's my origin. And I have a distance, I can go to the right 2 units or I can go to the left 2 units. So really what I'm saying here is what is inside here? X could equal a positive 2 or a negative 2. And you can write that as x equals positive and negative 2. So x itself can equal 2 or x can equal negative 2. Now think about that pattern and let's try this again with a binomial inside. So this time I'm going to write 2 equations again. Instead of x equals 2 and negative 2, I'm going to say x minus 2 can equal 4. Or this binomial, x minus 2, could also equal negative 4. So this entire value can equal 4, or this entire value could equal negative 4. And now we just have 2 equations that we're going to solve for our unknown. So I'm going to go back up here, and of course x here, I'm adding 2 to both sides to isolate my variable. X can equal 6, and down here, x can equal negative 4 plus 2 is negative 2. So when I write my answer, I'm just going to come down and write x equals negative 2 or 6. Those both satisfy the absolute value. So I'm going to go ahead and let's check and plug it in. Negative 2 minus 2 is negative 4. Is the absolute value of negative 4 4? Absolutely. Let's plug in 6. Is 6 minus 2 4? Is its absolute value equal to 4? Absolutely. And so what I do is I create 2 equations. What's inside the absolute value can equal positive 4, or what's inside can equal negative 4. And that's how we solve an absolute value equation, okay? Now, let's go to something a little bit trickier. What if the absolute value of x is less than 2? Less than 2, we have an inequality. So I want to find all numbers on the number line whose value is less than 2 units from the origin. Okay, so here's my origin, and I want to think of all the numbers whose distance from the origin is less than 2. Well, it's got to be less than 2, so it cannot equal 2, so I'm going to put open circles there. But I can see that this distance is 2 units, and so is this distance. So all of these numbers to the right of negative 2 are less than 2 units from the origin, and over here, all of these numbers less than 2 are also less than 2 units from the origin. And so my answer is this little segment here, not including the 2 endpoints, negative 2 and 2. And if you'll recall from before spring break, I know that's been a while, but we call this a conjunction. This is called a conjunction. And it's an and statement. And so I'm going to write this final solution as a conjunction. And so what I do is this. I say x could be any number less than 2 and greater than negative 2. And so here is my solution. You could write it out, x is less than 2, and then write the word and then write x and x is greater than negative 2. But I always prefer to write it in this condensed format, okay? So we have a conjunction, an and statement. X has to be all the numbers that are less than 2, and they have to be greater than negative 2, okay? Now, Let's look over here and make it a binomial inside the absolute value. Well, it's still going to be a conjunction. And so what I'm going to do is I'm going to create an and statement just like this, but instead of x being here in the middle of the and statement, I'm going to make x plus 1 be in the middle of the and statement. So I'm just going to write this as x plus 1 has to be less than or equal to 3, and that value can be greater than or equal to -3. So I've got the same pattern here. I've still got an and statement, but I now have a binomial here in the middle, and I have the range of 3 and -3. Now, you want to always write it with, you always have 2 less than or less than equal to symbols here with your variable in the middle, okay, or your binomial with the variable in the middle. Now, let's solve this. And we remember before spring break, to isolate x, we're going to subtract 1 from each of the 3 sections of the conjunction. So this will just become an x. I'm going to subtract 1 on the right side and subtract 1 on the left side, and I have a solution of x is less than or equal to 2 and greater than or equal to -4. Now, the homework will tell you to graph that. And so let's go ahead and do that. That is an and statement. My 2 endpoints are -4, -3, -2, -1, 0, 1, 2. I'm going to put a 2 here. Okay, I'm going to go ahead and put a 3 here and a -5. I think that'll make it look nicer. Now, let's go ahead. It can be equal to -4. It can be equal to +2. And x is all the numbers that are less than 2 and greater than -4. And so again, I have this segment here with my 2 endpoints. In this case, they are closed circles because I have an equal to here. Here, there is no equality. It's just less than. Okay. So that is our less than absolute values are always and statements or conjunctions. Now let's go to a greater than and see what happens. Now look at this. This is fun. Let's go ahead and flip to the other side, and I'm ready to go. So here we are. So now let's go to a greater than scenario. Let's start with a simple term of x inside first. So I have x is greater than or equal to 2. Now that means I want to graph all numbers on the number line whose distance from the origin is greater than or equal to 2 units, okay? So here's the origin, and it can be equal to 2, and so I could go 2 units to the right, or I could go 2 units to the left. It's just a distance, and this is a distance of 2, and so is this. So I'm in good shape. But now I want to graph not all the values that are just equal to 2 units from the origin, but are greater than 2 units from the origin. And so for it to be greater than 2 units from the origin, I would go this direction, okay, because all the numbers here are going to be more than 2 units away from the origin. Same thing over here. I'm going to go ahead and graph, that's a closed circle, it's a little bit open there. I'm going to graph all numbers from -2 going to the left, okay? So that is how I graph a greater than inequality. And we call this a disjunction. It's an and, it's an or statement. This is a disjunction. And how would I write that answer out? Well, unfortunately with or statements, there's no way to condense it into a nice, neat little package like we do with our and statements. And so I'm going to simply write x is less than or equal to -2, or, I have to put the or word in there, x is greater than or equal to +2. And that is my answer there. So let's move on. Sorry, someone's calling me. Now let's move on if we have a binomial here instead of just a monomial. Now, it's going to be the same pattern. It's going to be a disjunction. It's going to be an or statement. But I'm going to say that what's inside here, x minus 3, is greater than 2, or I'm running out of room here. X minus 3 is less than negative 2. So I can have what's inside can be greater than 2, or what's inside can be less than negative 2, just like we had over here. Now, let's go ahead and solve this. Now notice, I do want to say one thing here. When you split it up into two statements, the absolute value symbols go away. Do not leave your absolute value symbols here, okay? You have gotten rid of them and written your disjunction. You write two statements after you drop the symbols with disjunctions and conjunctions and equations too. All right, so let's go ahead and solve this. X is greater than 5 or X is less than 1. And that's my answer. X is greater than 5 or X is less than 1. Okay, now let's go ahead and graph that because your homework will ask you to graph it. So my two boundaries are 1, 2, 3, 4, and 5. I'm going to put a 6 just because I like to have something like that. Okay, now let's go ahead and graph it. X is greater than 5. So I'm going to go ahead and put an open circle and darken. I'm going to have a ray going to the right. And then less than 1, I'm going to have an open circle. And I'm going to darken the line and the arrow going that way. I'm going to fill these numbers in. Now, that looks really nice. Okay. So with a greater than absolute value, you're going to have an or statement. What's inside is greater than 2, or what's inside is less than negative 2. With an and, with a less than or less than or equal, you're going to have an and statement. Okay? What's inside is going to be less than your positive value and greater than the opposite of that value. So let's look at now something that is a little bit more difficult, and that is this problem. I picked this from the B's, all right? So we can look at that and make sure that you're okay when you're starting to do your homework. So I am going to go ahead and just get rid of this part right here, just so we don't run into a mess here. Now, let's see. There we go. Now, let's go ahead and solve this. Ooh, there's going to be some interesting things going on here. The first thing I want to do is isolate my absolute value. So I'm going to go ahead and do 2 minus q. The absolute value of 2 minus q is less than, I'm going to add 3 to both sides. Okay. Oh, well, I have an absolute value of this binomial is less than 4. This is a conjunction. This is an and statement because it's a less than. So I'm now going to convert this to an and statement and eliminate my absolute value symbols. So I have 2 minus q is less than 4, and 2 minus q is greater than negative 4. There is my and statement because it is a less than absolute value. Okay, now what am I going to do? Let's isolate q. Let's subtract 2 from all 3 sections. So I'm going to make that a negative q. I'm going to leave a less than sign. I'm going to subtract 2 from every section. So there's a 2 there, and then I'm going to subtract 2 and make that a negative 6. Okay, I need to isolate q now. So what I'm going to do is divide every term by negative 1. Ah, what do we have to do when we multiply or divide an inequality by a negative number? Can you remember from 2 weeks ago? We have to reverse the inequality. So let's reverse the inequality. We have q is greater than negative 2 and less than positive 6. Now, we never, ever, ever leave this with the smaller number on the right and the larger number on the left, and with greater than and greater than. We're going to rewrite this with q in the middle, and let's just see what this says. Q is greater than negative 2. So I'm going to rewrite that as q is greater than negative 2, but I'm going to go ahead and have my smaller value on the left side, and it's less than 6. And now I have my final answer, okay? And that looks like that. Now, what am I going to do? I'm going to graph it. Oh, yes. Now you have to think about what this is. Is this going to be a segment, or is it going to be two rays going out? Well, when it's a conjunction, an and statement like this, we're going to put our -2 and our 6. There's no equal, so I'm going to put open circles. Q can be all the numbers that are less than 6, but they also have to be greater than -2. And so that is just these numbers in here, okay? Your and statements will look like this. All righty. So that's our concept for today. And let's talk about the homework. I'm going to scoot over here. And the homework. You're going to do your LMS assignment. And I will tell you, I am only going to assign odd problems because I want you to be able to look at the answers in the back of the book and get feedback because I'm not there. Okay? So I know you also have, Slater.com works out some of the problems. I know some of you don't like that as much as others, but you can still use that resource. And I will tell you this, starting tomorrow, Mr. Bundy, on Tuesday, Mr. Bundy has said that my math classes are allowed to have a Zoom meeting as a tutorial. So I'm trying to think when we're having our meeting. Every afternoon at 1, no, I take it back. I think it's 11. I'll let you know for sure tomorrow. But you will have a Zoom meeting with me every morning at 11 if you want to. It's totally optional. It's totally optional. I will post the invitation to the meeting and the link to get into my meeting at 11. We'll talk about that a little bit more tomorrow. But so the meeting's at 11, so get your homework done in the morning, and if you have any questions, you can join the meeting and I can work problems with you just like when we're at school together. Now, the other thing you're going to have to do after you do the assignment, just on a plain piece of computer paper, please. Don't give me stuff with lines. I don't like it. Take a picture or use a scanning app and upload your assignment to LMS. Right under this, you're going to use wherever this assignment is in LMS, okay, for today, you're going to load it right there into the tab that has this specific assignment. Okay, it must be uploaded by 9 a.m. tomorrow. So if I teach it on Monday, it has to be uploaded by 9 a.m. on Tuesday. Okay, it's as if you brought it to school and you're going to give it to me at 9 a.m. So you have well into the evening to do it, but it has to be in by 9 a.m. the next morning. Okay, now we are going to have a quiz tomorrow, Tuesday, on 10:1 to 10:3. It will be open book. Everything is going to be open book. Okay, so I don't want you to panic about that because now you have your book to look up some things. And tomorrow I'll explain to you how we're going to take the quizzes. All right, so I'll put that in the beginning of our instructional video. So until tomorrow, work on those problem sets. I'm sorry I can't help you with Zoom today. I hope you can do this without me. If you need help, you can text me on the chat wall individually, or you can go to the class wall if you want to also. And everybody will see what you have a question about, but that's okay. So I'll help you the best I can tomorrow, and we will have a Zoom meeting on Tuesday if you need it. So I hope you have a blessed day, and I miss you very, very much. And I hope we'll be able to get together soon. But until then, work hard at home, and we'll try to make this as normal as we can. So I'll see you tomorrow. Bye-bye.